Hi there, my name is Lalit and I work as a technical architect for Ipinfusion. Today I am going to talk about one of our product offering called ZebM. So ZebM is a framework for developing the management solutions for different types of network element, let's say a switch or a router. This framework provides a set of APIs and tools which helps a management system developers to quickly develop or add the manageability to their systems without spending much time on writing the various components of the management systems. They can rather spend time on creating or organizing the data for their system which needs to be managed, rather than spending time on actually developing the different components of a management system. So in a way, ZebM helps the management system developers to quickly add the manageability to their applications and systems, and also reduce the time to market as well as cost for such developments. So let's look at a little bit more details about the ZebM. As I mentioned, it provides a framework for building management system for various different types of network elements, let's say a switch or a router. And the framework provides two set of programmatic APIs. One is transactional, which are ACID compliant. We also call it a CML API or Central Management Layer API. The other is non-transactional, which are equivalent, CLI equivalent programmatic APIs, and we also call it SMI APIs. These APIs can be easily integrated with a third-party northbound or southbound management applications. The framework also provides a set of tools for automatically generating most of the backend code for these management APIs. Here is the very high-level architecture of ZebM framework. So the framework consists of a CML engine. The CML engine is the component responsible for receiving the configuration requests from the various northbound applications, for example netcon for CLI or SNMP. The SMI APIs are towards the southbound. The CML engine uses the SMI API to send the configuration request to the device or the applications running inside the device. The data model is the abstraction of the resources which needs to be managed. So for example, if you want to manage the VLANs of a system, this data model should be written for that particular managed object called VLAN. And the CMLDB is the configuration store where the entire configurations data is stored. The interface between the CML engine and the CMLDB is ODBC. This has been used to ensure that the developers or various third-party application developers can replace this CMLDB with any SQL database of their own choice, and the interface between the CML engine and the database doesn't change. So the whole thing works like this. You want to add the manageability for your system. So first thing which you need to do is create the data model for your system. The data model will represent the abstraction of the resources of your system which you want to manage. The ZebM tools will be used to compile your data model and automatically generate the managed object code which gets hooked with the CML engine, and the SMI which gets hooked with the CML engine as well as your southbound applications responsible for managing the resources. Towards the northbound, we have the CML API layer which can hook to any northbound management application, let's say netcon for CLI or SNMP. So once you have written the data model, generated the necessary codes and built everything, your system is ready to be managed. To give you an example, let's say that you want to manage all the interfaces of your system. So what you are going to do is first create a data model for all the interfaces of your system. So the data model will basically represent the abstraction of the interface, various properties of the interface which needs to be managed, and various operations which you can perform on the interfaces of your system. Once our MO generator and SMI generator acts upon your data model, it automatically generates the managed object codes for the interface and the SMI API layer for your device, which will eventually perform the operations on the interfaces. Once these codes are automatically generated, you build the entire system and then your interfaces are ready to be managed. Towards the northbound, you can either use a CLI or SNMP or netconf to send the configuration request using the CML APIs to the CML engine. When the request lands on the CML engine, it will invoke the corresponding managed object to perform the operation on the particular interface. The managed object will use internally the SMI API to send the configuration to the device, and that is how the application the configurations will be performed on your system. Whatever configuration gets committed on your system will be also stored on the CMLDB, so that at any point of time you can request, or your management application can request the CMLDB to fetch all the data which are configured into your system. So basically it can provide at any time the runtime configurations of your system. Here is an example of a data model and the code which gets generated out of the data model. So say for example, your application is responsible for managing the bridge and you want to add the manageability to your application. So what you do is you create an abstract data model for the bridge using the data modeling language called XML. So you write the entire data model using the XML syntax. The schema is provided by the framework. Once the data model is ready, you use the MO generator tool to generate the necessary backend code. Once all the codes are generated and you build the system, you give a make in the main folder of ZebM, everything is ready. So you can use the CLI or you can use the SNMP to actually configure a bridge, create a bridge, delete a bridge, configure one of the property of the bridge, etc. using the northbound application, let's say CLI or SNMP, and those will be automatically performed using the CML framework to your application or to your system. So here is an example how a developer can write a management application using CML APIs. This example is a very simple API where you perform some few configuration operations as part of this application. So the developer starts with initializing the CML context. Before he can use any of the CML API, he must initialize the CML context, which actually sets the necessary IPC parameters between the management application and the CML engine, basically. So the CML init is the API. Here you need to pass your application name, which could be anything, XYZ, and the type of the transport which you want to use. In case your application is going to be running on the device itself, it could be Unix domain socket. If your application is supposed to run outside the device, somewhere else in the system, in the network, then you can use the TCP as the transport while initializing the CML context. So once the CML context is initialized, basically it returns you a CML context structure which needs to be passed in every subsequent CML API calls. The first thing which the developers do is start a transaction before performing any configuration operations. What is the meaning of a transaction is, you can perform a set of configurations atomically, which would mean that either the entire set of configuration will succeed, or in case there is any failure, there is a possibility to roll back the entire configuration, which means that the system state will be backed to what it was before actually you started performing any of the configuration which were part of this transaction. So once the transaction is acquired, you call different CML APIs either to create an object, to delete an object, and to perform the set for a particular attribute of a managed object, etc. So in this example, the two managed objects instances are getting created. One is bridge and the other one is VLAN. So you call CML create object with the managed object name as bridge. The distinguished name basically uniquely identifies the instance of this managed object, and you also provide a set of attribute list along with its values which you want to set while you want to create this object. Similarly, you use the CML create object to create an instance of a VLAN by passing the necessary parameters to CML create object API. Now, what exactly you have done is you have added two configuration operations into the transaction which you have just created. Both these configuration operations will get performed atomically, which would mean that either the creation of both bridge and VLAN will succeed. In case either bridge creation or VLAN creation fails, the entire transaction itself will fail, which means neither the bridge nor the VLAN will get created. So this is the notion of the transaction. You can group together a set of configuration requests into a transaction, and either the entire transaction will succeed or everything will fail. This is what we called that the APIs are ACID compliant. So when actually you are calling this API or when you are adding the configuration request as part of the transaction, at that point of time, CML framework triggers the validation for the various operations. So when you call CML create object with all the necessary parameters, internally the CML engine will trigger the validation for everything. The parameters which are passed are correct or not, whether the number of bridges which are supported by the system have already reached to its max so that no more bridge creation is possible. So all such kind of a static, dynamic or dependency validation will be performed by the CML engine at this stage. If the validation operation succeeds, the caller will be informed accordingly whether the validation succeeded or failed. Accordingly, the caller can take a decision, or the developer can take a decision whether to continue with the transaction or whether to abort the transaction in between. So let's assume that all the validation succeeded. So once the validation succeeded, you call a CML complete transaction API, which would be an indication to the CML engine that now you are done with adding the configuration request as part of this transaction. Now the CML engine will trigger the validation for the entire transaction, and if necessary, it will also regroup or reorder the configuration request to ensure that the entire transaction succeeds. To give you an example of reordering, let's say that CML create object for the VLAN came first, and later came the CML create object for the bridge. And this bridge was necessary for the VLAN to be created. In that case, when the complete transaction is called, the CML engine will automatically validate that the bridge needs to be created first and then only the VLAN can be created, and it reorders that configuration request in the transaction. Now, after the entire transaction is validated, the CML engine will inform the management application that everything is okay. At this stage, the application can call CML commit transaction, which would be an indication to the CML engine that now you can go ahead and perform this configuration onto the device. At this point of time, the CML engine uses the SMI API to perform the corresponding operation on the system. So it will basically create the bridge, create the VLAN onto the system using the SMI API. In case the validation for the transaction failed, the CML engine will accordingly inform the management application, and the management application has the possibility to call CML abort transaction, which will abort the entire transaction and bring the system to the state where it was before actually this transaction was started. So this is how a simple flow of an API using the CML works. This is one of the use case where basically you want to use netconf as a management application to manage some of the protocol modules which the ZebOS supports. So here in this example, we have shown NSM and MSTP at the two protocol modules using which needs to be managed using the netconf client and server. So what you need to do is first you create the data model for MSTP and NSM, and then that data model, the CML, basically the ZebM tools compiles this data model to generate all the necessary code, managed object code. This data model can also be exported using an export tool into a YANG model, which is required by the netconf server and the client. Now this YANG model, using this YANG model, you use the YANG dump tool to create or to generate a ZebOS netconf library. This ZebOS netconf library gets loaded into the netconf server and YANG CLI, and that is how your YANG module, your netconf, you are ready to manage the ZebOS protocol, some of the ZebOS protocol modules using the netconf client and server. So whenever you will perform some operation using the YANG CLI, using this ZebOS netconf library, the request will be routed to the CML engine, and once the CML engine receives that request, the CML engine will look for the corresponding SMI API to perform that operation on the protocol modules. This slide talks about how you can automatically render the CLI over CML using the ZebM framework. So when you have created a data model, it is expected that all the command line interfaces would get generated automatically using that data model. So here again, what happens is that when you create the data model, we have a set of tools which generates automatically the CLI out of the data model, and those CLI internally would use CML APIs to actually send the configuration request to the CML engine, and CML engine subsequently will use the SMI API to perform the configuration operations on the southbound applications or the system. So basically the CLI which automatically gets generated out of the data model, we call it CMLSH. The CMLSH presentation and backends are automatically generated, and the presentation can also be customized by specifying some CLI specific tags into the data model. So it is possible to basically generate a Cisco-like CLI for your switch or a router by customizing the data model using certain specific tags provided by the ZebM framework. So that was a very high-level description of our management framework. So if you want to add manageability to your system and you want to reduce your time to market, don't want to spend a lot of time on developing the different components of a management system, the ZebM is the framework for you. All you need to do is create the data model for your system and you are ready to go. Our framework will take care of automatically generating most of the management components which is required by your system to provide the manageability. Thank you for your time.